Okay, so good morning everyone and welcome to the session on the today's session on choosing the container cloud provisioning tool that best suits your needs. Before we begin the session, let me just introduce myself. I'm Pradeep Kumar. I work for Ericsson as a solution architect, and I also work on the network cloud, which is an AT&T initiative and which uses Kubernetes, Airship, and a couple of other containerized tools. Okay, so here is a brief agenda of what we will be talking about. To begin with, we just are going to spend a couple of minutes on why containers are needed for cloud provisioning, and also why containerized OpenStack deployment, and also the key attributes of containerized deployments, and a brief overview of Airship, Kolla, TripleO, and then we end up with the comparison. So I'm sure all of us are familiar with containers here, and just to brief and just to bring the context here, containers are in the picture now, right? Pretty much OpenStack is moving towards the containers, and the reason why we are moving into containers are because the microservices help decompose some of the monolithic complex operations into the composable parts, smaller composable parts. And apart from that, it also brings the services up and down pretty quickly. And apart from that, you also can scale, upgrade, and monitor them separately, independently. And thus increasing the efficiency, reliability, and the scalability part as well. And the most important thing is that it is open source, and that fosters innovation and rapid development. So here is a picture that most of us would be aware of, and we would have seen it tons of times. And what we are looking at is the bottommost stack, which talks about the lifecycle OpenStack management, and that forms the undercloud, and that is what we are talking about, and that is what we provisions on the container. So there are few tools here. The most popular tools are Kolla-Ansible, and then we have TripleO, and we also have a new initiative called Airship, which is an OpenStack project, and we'll be talking about them in the coming slides. So while choosing the containerized cloud provisioning tools, these are some of the attributes or features that we need to look for, and these are the things that we need to consider before choosing the tools. And some of them are container technologies and tools. So as we know, there are various solutions for this: Dockers, Kubernetes, and we also have OpenStack, the Helm, and also we have Docker Swarm, to name some of the few. So we need to choose one of them, whichever suits our needs. And we also need to consider the deployment strategies. I'll talk more about that in the coming slides, and the infrastructure configurations, storage, logging monitoring, bare metal provisioning, networking, which is the CNI, and then the storage support, and then the most important thing, which is the day-to operations and upgrades. So today we will be comparing these three tools, which to me are some of the most popular tools, and they add a lot of value when you're considering a containerized deployment. So the Airship, the Kolla, and the TripleO. Now let me hand it over to Hemant for an introduction on Airship.
Yep. Let's talk about Airship. Airship is basically loosely coupled components. It contains some open source components like OpenStack Helm, Kubernetes. It embraces them, and also Airship itself have some projects which are open source. So all these components, loosely coupled components, integrated together forms the Airship, which in a declarative way you can deploy your OpenStack Cloud. It also gives you a full life cycle of data center management, right from the configuration of your bare metal nodes to the OpenStack services, controllers, and computes. So all these declarations will be done via YAML manifests. So that is the basic agenda of Airship. Every declaration should be a YAML manifest in a declarative way. So it's not about what or how or what is our end goal. What need to be done on the bare metal host? That's what we define in our YAML manifests. So this is the Airship architecture. Most prominent in any architecture we see this when you look at Kubernetes or containers. So we have the bare metal and we have the host OS. On top of it, we have the we have the Kubernetes cluster, and here you can see in this line there are some components, some open source components like Ceph and Calico, Ceph for storage and Calico, and there are some components in blue which forms the Airship components. And then we have infra components for monitoring and logging, and then the OpenStack components. So all this together will form the Airship to deploy on your cloud. And then this can be embraced with the CI/CD pipelines as well. Now, let's look from a different perspective. If I am doing a deployment of a site, okay, so I am using Airship. So how do I define my manifest as per my site definition? How do I design it? So we will look into each of the components, how it enables us to do that. So let's start with one of the component, deckhand. Deckhand is basically the YAML manifest document. I call it a document storage solution. So you put all your manifests in the deckhand. It's not just the storage solution, but deckhand provides something else. It provides a functionality called layering. Means if you have, let's say you have many manifest files, you can define a parent and child relationship between your manifests. Just to give a context or example, I have to deploy 20 sites, and in 20 sites, I am going to deploy a particular release of OpenStack, so particular release of Helm charts and particular release of manifests. So I need not define all this information for each site. Rather, what I do some definitions in the global level, and then do some definitions at another intermediary level, and some more definitions at the site level. So basically, site level contains only information like how many bare metal hosts I have, what are the IP addresses or the network topology of that site. Those information will be at the bare metal. So, that concept is provided by deckhand layering. And also deckhand also supports substitution. Substitution of a YAML documents, some content within the YAML documents. What do I mean by that? Let's take an example. You want some certificate information for a Kubernetes cluster to bring up. When you build the manifest, you build it today, but you want to deploy it after 1 month. So your certificates, let's say, they will come after 1 month. So you can tell that, okay, this is my document name where my certificate will come, substitute it. You can define it in your manifest. So that is the kind of flexibility that deckhand will give for the site design. And then moving forward, promenade component is useful for your installation and upgrade of the Kubernetes layer itself. So it gives you a couple of scripts to do all the single node self-hosted Kubernetes cluster, and then you can join nodes. All the scripts, everything will be provided by this component. And then there is one more component called Armada. To deploy any Helm charts, you require a tiller service, at least in the current releases, right? So Armada provides us the tiller service for you in the Airship. It's not just tiller service, it has something else as well. So you have 20 charts. You have Keystone chart, you have dependency on MariaDB chart, and then MariaDB is dependent on Ceph chart. So how do you sequence them? We can do it via Kubernetes dependency jobs, but if you do that, what happens? If you just deploy it without any sequencing, you get hundreds of pods. Some pods will be init state, waiting for the other pods to come up, like MariaDB to come up, Keystone will be still waiting. What happens if Ceph is down completely? Some pods will be still in init state, some pods will be waiting for PVCs and getting crash loop back off, and all this stuff will happen, which is a chaos to debug. So what we do is we do it as you can define it as a sequence level. You can tell Airship that I want Ceph to be completed. Once it is successful, then go to the next step and deploy the other MariaDB kind of services, and then go to the next step of OpenStack components. So you can define that kind of flow. And then there is a dry dock component, which is basically allows you to define your bare metal configuration in a declarative way. So all your host configurations, network configurations on the host, as well as storage configurations on the host, you can define it in a declarative way. And also all your BIOS settings, RAID settings, the bare metal server management also can be done by the dry dock component. On a backend, it provides a plugin kind of model, and it uses MAS today. and there are plans to integrate it with Cluster API with Metal Cube, which gives the ironic way of deploying. And the shipyard component is the orchestrator of all these jobs together. So it uses the Airflow as a backend. So there are some plans to use the Kubernetes native Argo workflows because it is a directed acyclic graph basically. So we can use the Kubernetes native first class citizen Argo instead of an external tool. So that's the plan with that. So this is the workflow of the Airship. On the left hand side you can see all the artifacts. So basically the artifacts will contain Helm charts for all your services. When I say services, it's not just OpenStack, it also includes your Airship components as well. And then you have all the YML manifests, bare metal, including bare metal to service configurations, in any service configurations, all this will be defined in the bare metal manifest files. And you can also define your security policies like the Calico policies, etc. as a manifest. And the networks are basically the network topology of your site you can define in the YML manifest. So all this together will become as an input to your Airship. So when you give all this input to Airship, it goes to the shipyard and the rest of the components and it deploys the cloud. Okay. So that is the second box talking about. Let's say we want to change a configuration now. Let's say Keystone configuration, we want to change the backend. So the way to do it is, again, update your manifest and go through the same process which you have gone in the greenfield deployment. So from the process point of view, it's still the same. Go to Airship shipyard, update your manifest, tell Airship to update my site, and it will do update your site. And it maintains all the latest configuration in the deckhand. What it allows us as well is, on a given site, we can always go to deckhand and see, okay, this is the configuration I have asked to do, and this is the configuration I have. And probably 2 days back, I have this configuration. I can see what are the changes I have done on this site. So that is kind of flexibility that is given. Okay. So the Airship workflow, you have 2 boxes here. One is at the build time, one is at the runtime. At the build time, you can see different templates as we spoke, all the YML manifests, application templates, Helm charts, passwords, certificates, everything, and site level information YMLs. All the YMLs can be given to a tool within the Airship called pegleg. The pegleg will collect what are all the required manifests from all the set of the tools, and then it generates a single file, single big file which contains all the required YMLs. So if you have so many YMLs here, we might not require for this set all of them. So pegleg will filter them and combine and validate them as well, do some linting and get this site.yml. And we will use promenade component to generate the Genesis script, some scripts which can self-host your Kubernetes layer. So these two will be the output of your build time, which can be done on any server in your local. Once it is done, this is your site, let's say, and we are designing for 4 controllers and 2 workers. So we define one node as a seed node. We call it here as a Genesis node. So Genesis node, install your OS or use a CI/CD pipeline to do all that stuff, and give these 2 inputs to the Genesis node. Run this genesis.sh script. That script will bring your Kubernetes cluster single node, and then it will bring your CNI, it will bring your Ceph storage things, it will bring your UCP or Airship components on this. So after the completion of this script, you will have only the Airship components, and it's a single node. Once you provided this site.yml to the shipyard, which is running on this Genesis node, then it starts all the triggering of deploying all the bare metal hosts, and then all the software bare metal hosts, as well as doing all the YML manifests and deploying all your OpenStack services, etc., will be done through this shipyard. And the Genesis node will become part of the cluster of the other controller nodes. Okay. One more strategy, deployment strategy, which is provided in Airship is, let's say you can define such that I want to deploy 4 controller nodes first, and then I will, if 80% of them are successful, then go and deploy compute nodes. So you can define such kind of conditions in your manifest files. And even if, let's say, you have 100 compute nodes, you want to do it 10 of them in parallel, you can define all those kind of conditions in your manifest files. So this is what Airship provides. Yeah, let's move to Kolla, how Kolla works.
Thank you. So moving on to Kolla. So Kolla has been there since a while, and we know that Kolla uses Ansible to actually orchestrate the container deployments. So this gives an overview architecture of how Kolla works. Kolla basically has two components, which is the Kolla image component and the other Kolla-Ansible component. So if you see this, the green arrow that shows basically Kolla talks to the Docker registry, which contains the images, the OpenStack images. There are two ways that you can host an image. One is a public repository or a private registry. So if you are using a public repository, you can use either a Docker Hub or a Docker IO and then pull the images from there. Or if you want to customize them and maintain those images locally, you can also have a private repo hosted on your bare metal. So the Ansible part is responsible for bootstrapping your compute and control nodes. So this primarily would run some Ansible playbooks, and it would ensure that the nodes get the images from the private or the public repos, and then deploy the control based on whether the target is the control node. It goes and deploys the control components, the OpenStack components. If it's a compute, then it would just install the agents on that. And obviously, the storage also you can configure on the Ansible playbook. So like I told you, there are basically the OpenStack repository where you get all the Docker files available there. All you need to do is probably pull them directly if you don't want to customize them. Or if you want to host a private repo, then you pull them on the base image. You can customize them and keep them locally in the Kolla images private repo. And then the Ansible, like I mentioned, it is used for deploying your cloud, the containerized cloud, the under-cloud platform, I would say. So typically, a image build process can be triggered using a Ansible CLI, the Kolla-Ansible CLI. That provides, this is the syntax, if you can see, this is the syntax. You need to just provide the component that you're trying to install. And you need to, as a prerequisite, you need to configure the Kolla build.conf, wherein you provide all the base images that you're trying to pull. So there are three ways you can pull. One of them is a URL. Using a URL, you can pull the images, or you can also pull it from HTTPS using a Git or a HTTPS. And also, you can have a local repo, which is going to be a file within your local machine. So, or you can provide a tarball, again, locally as well. So these are the ways you can provide the images. So once you have built the images, the deployment model would basically consist of 4 steps, I would say. The first step is the baselining. So you need to have an OS installed. You need to have the prerequisites for Kolla-Ansible that needs to be met on the OS, which can be done using pip or any other apt-get, or if you're talking about the Debian, you can do an apt-get. And also, you need to ensure that the Kolla tools are already existing on your host, which would be your seed node where you would trigger the deployment. And then you would also have to ensure that a Docker is installed, a correct version of Docker is installed, shared mount points are enabled, and also have a secure registry or the TLS certificates installed in case you are using a local repo. So the deployment part basically consists of 2 important files, the globals.yaml and the passwords.yaml. The globals.yaml is a file which consists of all the components or services that you would want to enable. I will quickly show you the files, and the passwords consists of custom passwords that you would want to set for those services. Or if you want to use the default, it also provides a Kolla gen password tool, wherein you just run the tool and it will generate the passwords for you for all the components. Let me just quickly show you the file. So this is how a file would look like. On the left-hand side, you see the globals.yaml. It talks about all the services that you would want to enable here. This is a sample file, so I've disabled most of them. And then on the right side, you have the password files for, and the attributes that you need to set for appropriate components. So the fourth step as part of the deployment is setting up a multi-node inventory. So in order to set up a multi-node, you need to first come up with an inventory file, which gives you the basic information of all the nodes that you're trying to bootstrap. And then once you run the bootstrap servers command, it will go and deploy the prerequisite tools and also ensure that they are part of, they are understood by Kolla, whether it's a compute or a control node. So that's a mandatory step that you need to do in case of a multi-node. And then you start the deployment using the Kolla-Ansible deploy command. So let's move on to the TripleO feature.
Okay. Like in Airship, how we have seen the undercloud, which is the Airship, and the overcloud, which is the OpenStack. TripleO has a similar mechanism, the undercloud and the overcloud. The best part of TripleO undercloud is it reuses the OpenStack itself as its undercloud, which I feel very good because it is using the open source components for the undercloud. So the undercloud will be responsible for deploying your overcloud. So it has certain manifest files which will help you in that. So the undercloud will be responsible for all your deployments, updates, upgrades, as well as your monitoring stuff. And your overcloud is for the tenant management. So this is the physical view of the undercloud and overcloud. You can see on the undercloud, you can see all the OpenStack components running, and on the overcloud, you can see all the OpenStack components running. So this is the same even if you consider VM-based deployment or the containerized based deployment. All the services are same. It is just they are running as a process in the VM-based deployments. Now it is running as a containers. Okay. So if you see here, we have Ironic, which will help the undercloud to deploy the bare metal nodes, and all the images, OS images, kernel images, everything can be stored in the glance image. So this is the deployment workflow for the TripleO. So there are set of environment requirements where we define, this is the place where the user will define what he requires in the environment for the undercloud, what needs to be enabled, what needs to be disabled, what services he wants as part of the undercloud, all will be defined as part of this environment requirements. And this will trigger installation of that undercloud, and then it prepares the glance images which are required for the Ironic or the bare metal bootstrap, OS bootstrap. And then second part is it has to get all the container images for all the services. So it will pull all the container images. If it is it can be from external registry, or we can store a local registry and we can bring them up. Once it is done, it will register all the bare metal nodes, and then you tag them with a whether it is a controller component or whether it is a compute component, and you define your network strategy and SSL certificates, everything, and then you define all your clouds, overcloud related configuration as well here in this step, and your overcloud will be deployed. So I will walk through a couple of important steps in this. So these are the components of containerized TripleO. The first step is Docker image build. So Kolla project has been used for the Docker image build. So as we have seen in the last slides, we have seen the process of Kolla image build. So the same process has been used for here. And then all the configuration will be auto-generated. The user will specify some configuration, but there are lot of configuration files that needs to be auto-generated, which can be understood by the corresponding tools which come in the later stages. So we have a Docker Puppet. Basically, they have a Puppet script or a Python script which can be used, which takes the user information and then generate all the config files. And then for the container management, TripleO doesn't use Kubernetes as its container management. It uses something called Punch, which is a lightweight container management tool. Okay, and they have in their roadmap to move towards a new tool called Podman. which will help in integration with the containerd directly, and then using that they can use with containerd, kubelet, and slowly move towards the Kubernetes. So that could be the strategy of the TripleO to move towards the Kubernetes. And for the updates and upgrades, we will have the Ansible scripts for all the updates and upgrades and the heat templates. Even in the normal one, we will have heat templates to do all the ironic stuff. Everything is defined in the heat template. So this is the way the Docker config files have been, the configuration have been auto-generated. So you will have a JSON file where all the user-defined configurations will be there, and the Docker puppet.py script, it runs in a container, brings up a Puppet, and it has its own Hira, and it from the JSON it grabs all the information and it generates configs, and this config files will be an input to the next stage. So it will be an input to your Paunch container management to do all the Paunch stuff, and it will be also be an input to your pacemaker, CoroSync, etc. One thing which I missed is the Paunch will be used for the stateless applications, but for the stateful applications, the pacemaker CoroSync will be used for managing them. So it is as good as a VM-based deployment because it is a proven architecture with all the pacemaker and stuff. So they have used similar architecture here itself. Okay, what happens when pacemaker started a container for a service? So when you start a service container, it's not like a Kubernetes pod. So what it has is it has a couple of things as input: config JSON and the config directory. So this config JSON contains all the configurations. Like let's take an example of Keystone. So it will have a Keystone configuration file and the process of Keystone or the Docker image of the Keystone, process of the Keystone, etc. So the first process that will be triggered as part of this container is the Kolla-start, which copies all these files to the necessary directories within the container, and it sets necessary permissions. Once it is done, it will actually trigger the process, the Keystone process, let's say. So this is how the Kolla-start will work. So the key takeaways for me from the TripleO is they mostly used the reference architecture, which is a proven architecture for VM based. They used the same, and they made your services into a containerized, Docker based containerized one. Yep. With that, we will go to the comparisons of how we compare all the three tools. Pradeep.
Thanks, Hemant. Yeah, so we've seen a lot of architecture and how they're deployed in a typical environment. Now, the most important thing is the comparison that we would all be interested in. So how they are different from each other. What are the tools? Like I mentioned in the earlier slides, we want to understand the various parameters that you need to consider while using a containerized cloud provisioning tool. So let's start with the Kolla-Ansible, or rather the Kolla component. So it uses Docker only, it doesn't use Kubernetes. The container type is Docker. The orchestration is still done by Ansible, no Kubernetes there. And the supported containers are only Kolla containers. And TripleO pretty much uses Kolla underneath it, so it uses Ansible and Docker to do the orchestration and container management. Coming to Airship, Airship uses the low-key containers, which are the lightweight OCI containers. And for orchestration and management, it uses Kubernetes and Helm charts. So this pretty much, again, summarizes the same thing. Just to add up, we are not comparing Kolla because inherently Kolla uses, or rather TripleO uses Kolla, and so a lot of these functionalities that I'm talking about TripleO would remain common for Kolla as well. So for TripleO, we would have those additional tools that Hemant mentioned, which are Paunch, and also the Podman that's coming up in the later releases, and then Kolla-Ansible for orchestration. And the image builds also are done through Kolla component, Kolla image component. Now, the other important parameter that we need to consider while doing a containerized cloud deployment are the infrastructure configurations. How difficult or how complex are the infrastructure configurations? So we did go through about Airship. So as Hemant said, Airship uses a lot of manifests in the form of YAML files, which define the sites at a global level, type level, and the site level. Now, how does it differ? it's simple because if you have a global structure, you don't need to really go and edit them day in and day out depending on different environments. So you can ensure that this remains common across all the sites, and you don't need to modify them, I would say, frequently. Whereas the site level, it would probably need some modifications like your network interfaces or your storage interfaces in case if you're using a NFS or something, then that needs to be considered at the site level. So that differs based on what kind of hardware you're using. And then it uses, typically if you look at the treasure map where the manifests are maintained, gets updated with the global level configurations typically every month. So that way you can rely on this manifest to be updated with all the integration, the newer components integration pretty frequently and up to date. So with manifests, obviously the complexity increases because you need to understand how the manifests are written. You need to understand the schemas behind the manifests. So that is something that probably you need to consider while doing the development. But that also brings an advantage, which is you don't really need to touch the code. All you need to do is just go and change your configuration files, and that would take care of going and deploying the components. For example, if you want to add any new component on OpenStack, all you need to do is go and add the manifest, and appropriate Helm chart should be available, and you just modify the configuration files and you're good to go. You don't really need to change anything else. Whereas in contrast to what manifests do, TripleO would need an Ansible playbook. So suppose you're bringing in a new component, then you will need to write a playbook which would do the deployment of the new components. So you can see that there are three major components that you need to touch upon whenever you're bringing in new components or modifications: the Puppet services or the Docker image services, and the extra config, which is the site level details that you need to consider. But all these things are mostly YAML based and Ansible based. So since the community is mature on Ansible, this is also one of the good ways that you can actually use for deployment. On the deployment strategy, here is where probably you see a little difference. We call this a seed node versus a Genesis node. So in Airship, we use a Genesis node which forms your undercloud platform. So what Genesis node would do is it brings up your undercloud on the Kubernetes cluster, and then it also hosts your OpenStack on the same cluster, and then it becomes one of your controllers. I mean, if you're typically going for a 3-node cluster or a 3-controller cluster, then you would have your Genesis node, which is the bootstrap or the seed kind of a node, also becoming a control node by itself once the deployment is complete. So that way, you would have all of these undercloud components residing on the control plane. So that makes it easier for you to update. That makes it easy for you to push in any minor upgrades. So I mean, you don't really need to have a dedicated host for seed node, which is not the case here. So you can save some of the compute resources. Again, in contrast to what TripleO gives, TripleO would basically have a seed node that is explicitly used for deployment of undercloud, and that brings, let's say, for example, in this case, that brings up OpenStack, which is the undercloud OpenStack one node, and then undercloud OpenStack is used to bring up another overcloud OpenStack. And then once the undercloud and overcloud are deployed, you typically do not want to keep those bare metal hosts, which is the seed node, until you want to do an upgrade or put some patches. So then you can bring down them, shut it down, and then bring them on demand whenever you need to do an upgrade.
I just want to add one point here. So TripleO, you can use a single undercloud to deploy multiple overclouds. Whereas in Airship, the undercloud and overcloud lays on the same bare metal host. So it is 1:1 ratio in the Airship.
Right. So the next important strategy that we need to consider are the container networking interfaces. So Airship has a strong support of the CNIs like Calico and Flannel and a lot of other tools. Calico is a pretty popular tool that helps us do the container east-west and the north-south networking policies. You can also set the security policies on network using the firewall rules, which is orchestrated through Calico. And then you also can have them incorporated. Any new CNI plugins can be incorporated through manifests, like I told you, which is one of the benefits of having a configurable infrastructure deployment. And in case of TripleO pretty much uses a similar, a host level networking, which is similar to a non-containerized TripleO. It does not have any CNIs built into it. So it uses a Docker host driver, wherein the networking would happen through the host driver itself, the host interface itself. So another important thing, which is the security. Kubernetes, since we are leveraging Kubernetes in Airship, so we will be able to leverage most of the native Kubernetes security features, like your pod security policies, authorization authentication, and your RBAC, data encryption, and you also can do a resource access restriction. So all these things are built into by default. You don't really need to have it developed in-house, or you don't need to put additional code in order to secure your cloud. And also, Kubernetes provides additional advantage, which is integration with third-party apps. So that also is a benefit when you're considering security. So, and also this provides the other security features, such as AppArmor. I'm sure a lot of you know about AppArmor, which is a Linux kernel security module that allows the system administrators to restrict a program's capability. So that is what AppArmor would do. And similarly, even SecComp has been there. So SecComp also provides a user space program to set up a syscall filter. So in case of TripleO, there is a component within TripleO which is called AIDE, which is basically advanced intrusion detection environment, which is used to ensure that there are no unauthorized file tampering of those Ansible playbooks or any of the files, the configuration files within the container cloud. So that is how they ensure that the security is maintained. In terms of network security, it is mostly the firewall management rules which are on the host level, the IP table rules. Also, the logging, monitoring, and auditing. So with Airship, you can leverage the EFK stack that comes for logging features, which is the Fluentd, Elasticsearch, and Kibana. So you would be able to leverage them directly. Even TripleO has the Fluentd integrated, but we got to know that Fluentd is being deprecated on TripleO in some of the future releases. But at least today, we still use Fluentd and Elasticsearch and Kibana. And for monitoring, Airship uses Prometheus, Elasticsearch, and Grafana. And for TripleO, again, Sensu is being used. But again, that's in the process of getting deprecated. And they will be coming up with a new set of frameworks. So on the storage part, Airship currently supports Ceph for your undercloud storage management. And it also has an NFS driver, but largely for production environments, Ceph is largely used. In case of TripleO, that also supports Ceph and NFS storage drivers. Since we have an undercloud Cinder and Swift because of the OpenStack on the undercloud, it also supports the Cinder and Swift object storage as well as a backend. So lastly, the updates and upgrades. So how easy is it to upgrade and update your environment from the undercloud perspective? So a typical process in Airship consists of your manifest, like Hemant said in the earlier slides. All you need to do is touch the manifest files, make some modifications, and you follow the same set of steps that you do for a greenfield deployment. So that would ensure that I wouldn't say it is. It would override some of the earlier settings, but if you want to keep that as a independent operation, or if you want to ensure that the updates aren't touching the user-defined files, you can also do that on Airship. And then the host, which is basically the idempotent feature, is what I was talking about. So we also, since we have kubelets and Dockers, the host impacting components, if we see vulnerabilities, like we saw some security vulnerabilities on Kubernetes recently, and if you want to do an upgrade of Kubernetes on your environment, then you need to, you need to bring down, or you need to ensure that the Kubernetes is upgraded without any issues on the other components of Airship. So this can be achieved using Argo workflows, which are actually in work in progress currently, and that ensures that the workflow is appropriately first upgrading Kubernetes without hampering the other undercloud components. And when it comes to the other components of Airship itself, which are, suppose you want to upgrade Armada or Deckhand and other features, this can be just done using the Helm charts. All you need to do is update the Helm charts, and you would be able to upgrade them seamlessly. In case of TripleO, the TripleO performs the update via a concept called FFU. The FFU is basically a framework which ensures that, suppose, let's say we are upgrading the undercloud OpenStack from Rocky to later maybe Stain or Train. So first, it ensures that the stable release or the latest release of Rocky is first updated on the undercloud, and then once that is successful, it would go and update it to the later releases. So it is just a checkpoint strategy in order to ensure that there are no failures, because that is one of the pain points that we have seen in the past. Yeah, that pretty much summarizes the features. If anybody has any questions, not sure if we have any time left.
Okay.
Okay, if not, thank you so much.
Thank you.